So again, happy Tuesday for those of you who just came in. Happy Tuesday. We're going to start classwork today. So this is going to be really short. I'm just going to explain a couple of phrases to make sure you understand what those phrases mean. And then we're going to go through a problem, following the 4 steps of problem solving. And then I'm going to set you free to finish the classwork. Your classwork is just 8 problems. These 4, which are angle of elevation, and these 4, which are angle of depression. So let's talk about what is angle of elevation. It's really simple, right? Here's the word definition. Angle of elevation is when looking up at an object, the angle of elevation is formed by an observer's line of sight and a horizontal line. So what do we mean by line of sight? Well, just imagine lasers come straight out of your eyes, whatever you're looking at. So if you're looking straight, then the laser is straight and horizontal. Okay, kind of like this kid right here, right? So if he's looking straight, if he's looking straight, this is his line of sight, straight ahead, horizontal. And then if he tilts his head up, now his line of sight is looking up here. That angle he formed from straight to up, that angle here is called your angle of elevation because it's elevated, it's up. That's all that means, right? And your line of sight is like an imaginary laser coming out of your eyes to the thing you're looking at. So when you're looking straight, you're just going straight horizontal to whatever's in front of you. And then you tilt your head up. And you're looking at the top of this thing. Now your line of sight, your imaginary laser. And that angle that's formed from straight to up is your angle of elevation. Now the opposite is also true and it has a different name. We also have an angle of depression. Angle of depression is just the opposite. It's just the opposite. When you are looking down to an object, the angle of depression is formed by an observer's line of sight and a horizontal line. So if we're here, let's see this lifeguard here. He's sitting up on a platform, right? And so his line of sight, that imaginary laser, is straight. And then if he looks down at a swimmer, right, there's his line of sight. Now he's looking at the swimmer. That angle formed by tilting his head down, that's called your angle of depression. Okay, so those are some of the things, those are 2 big phrases you're going to see in all of these problems. And so you're going to need to know what that is when you are in understanding what the problem is. Okay, so we have 4 examples of angle of depression and 4 examples of angles of elevation. That's your classwork for today and tomorrow. So let's do number 1. Let's do number 1 together, but let's revisit the 4 steps to problem solving. Right? And I'm telling you, these 4 steps don't just help in math problems, they help in any problem you have. Almost 90% of problems you have can be solved by following these steps. I know there's some special problems that won't be solved by this. But most can. Not just math problems, but we're going to apply it to math problems because this is a math class. So step 1. Anyone remember step 1? And it's not solved because that's the problem. Those of you that suck at word problems is because you try to solve it right away. You read it, you look at the numbers, and then you add them or you multiply them or you try to do something already. You try to get an answer right away. That's the wrong way to do it. Step 1 is not everyone at once, please, one at a time. Step 1 in the steps to problem solving that we've been discussing all year is understand. Very good. You need to understand. And what I mean by that is understand the situation that's going on. Don't worry about numbers. Don't worry about formulas. Don't worry about math at all. Just look at the situation. Do you understand what's going on? Do you know how that stuff works? If it's about shopping, do you know how shopping works? If it's about paying for something with taxes and discounts, do you know how that works? Right? Don't worry about the actual numbers and percentages and formulas and nothing about that. Just understand, do you know how life works in that situation? And if you don't, then look it up or ask an adult. Hey, I don't know how to shop. I've never been shopping. How does shopping work with sales tax and discounts? And what does that mean? And then a parent or somebody older will say, oh, you blah, blah, blah. And they'll explain how shopping works, right? Okay, so understand the problem. Then step 2. Okay, once you understand what's going on, ignoring the math, ignoring the numbers, just know the situation. Then step 2 is when you come up with a plan and you start to connect that situation to what you've been learning in class. Oh, and another thing for understand, you should draw a picture or diagram. It's very helpful. Now, not everything that requires a picture or diagram, but most times a picture or diagram will help you understand a lot better, because I know most of you are visual people, right? Visual people. So step 2, plan and connect. So when you look at your situation and everything in your little drawing, you might see a right triangle, you might see a circle, you might see a quadrilateral, you might see something and go, oh, wait a second. We're studying this in math class. And then that's where you start connecting. Okay, that's a right triangle. And we've been talking about right triangles. Oh, I know that angle on that side. Oh, that's the opposite side of that angle. Oh, wait a second. That might be sine because that's a hypotenuse. This stuff starts happening. Start labeling your diagram with numbers. So now you actually start looking at the numbers, right? You might have to use a formula now and that kind of stuff. So once you've planned it, once you connected it to the real situation and what you've been learning, now it's time, step 3, to solve. Go ahead and solve that formula. Go ahead and get the x by itself or whatever you're doing, because you already have your plan. You understand what's going on. Now you just solve it. And then step 4, which a lot of you skip, is to check your answer. Make sure it's reasonable, right? If you're trying to find the height of a building and you get 2.7 feet, maybe you should go back and redo something or look at your work and see if you did something wrong, because a building shouldn't be 3.5 feet. You should not be taller than a building. That kind of stuff. So you check your answer. All right, so let's do that. So let's read this problem and let's understand what's going on, and then we'll connect. So Casey. Okay, Casey's a person. So Casey. Okay, now I don't like the way they word this. Casey sights the top of an 80-foot tall lighthouse. Sights? I would say, you know what? That's a horrible word. Casey sees, right? Casey sees the top of an 80-foot tall lighthouse. Now, I think they say sights because, like, I don't know. I'm thinking because when you have when you have a gun and then you have a sight at the top, right, with the little crosshairs, and you try to get something into your sight. So I guess that's where they're saying that, but that's not how we talk. So Casey sees the top of a lighthouse. See how I skipped the number? Because step 1, we don't care about numbers. So Casey looks at the top of an 80-foot tall lighthouse. What the heck? Some of you might go, what the heck's a lighthouse? I don't know what a lighthouse is. So guess what you can do? Guess what you can do if you don't know what a lighthouse is. Go to Google and Google lighthouse. And then look at images. Bam, those are lighthouses. And some of you are looking at this and going, oh, okay. Yeah, there are literally these towers that are either on a tiny little piece of land or on the edge of the land right at the ocean. And it has a light. If you see here, it has a light at the top. That's why they call it a lighthouse. They have a light at the top that spins around and around to let ships know, hey, land is right here. Be careful. Right? So that's a lighthouse. So there's a bunch of pictures. Okay, that's a lighthouse. I get it now. Go back to the problem. So we have a lighthouse and an angle of elevation of blah, blah, blah. So he's looking straight, and then he looks up at the top of a lighthouse, and he creates an angle of elevation. Don't worry about what it is. If Casey is 6 feet tall, okay, Casey, this is a tall person. How far is he standing from the base? Base just means bottom of the lighthouse. Okay, so we can make a little drawing. So we have this kid. There's Casey. I think he's a kid. He or she. Well, 6 feet tall, maybe not a kid, right? Okay, so this person. And then here's a lighthouse. Here's the top of the lighthouse. And, oh, wait a second. This looks familiar. Doesn't it kind of look like what's happening over here? Doesn't that that is a line. Wait a second. Look, if you can save time and use another person's drawing, why not? Why not? Why draw it from scratch? Okay, so I'm going to use this. This is what was up here. So I'm pretty sure it's connected, right? So here's Casey. Okay. And Casey's line of sight. Casey looks forward. Casey looks forward at the lighthouse and then looks up at the top. And now Casey's line of sight looks at the top. And we formed, and I'm going to put the triangle here actually. And this angle that is formed is the angle of elevation. Okay. And they say, okay, that's it. I think that's pretty much it. Oh, and they want to know how far Casey is from the bottom of the warehouse, from here to here. So that's the base of the warehouse. The lighthouse. Base of lighthouse. Okay, so they want to know that. Okay, we get it. We got a kid, 6 feet tall, or certain, don't worry about the numbers. I'm sorry. A certain amount tall, looking up at a lighthouse, forms an angle. They want to know how far is Casey from the bottom of the lighthouse. Okay, so do we understand the problem? I think we do. Are there any questions? So this is what you need to do. Now, some of you are saying, Mister, that took forever. Not really. I was going a little slower because I am explaining this to 20-some people. So I am going a little slower than usual. But, I mean, you could go that slow too. But just we need to take some time to understand what's going on. So now we go to step 2 and say, okay, is there anything here that can connect to what we're learning? And look at what's formed by Casey's line of sight. A right triangle. And let's start labeling stuff. We know Casey is 6 feet tall because they said that in here. They also say the lighthouse is 84 feet tall. So that means the lighthouse, that means from here to here is 84 feet. Okay. And the angle of elevation from him looking up is 58 degrees. So we can put 58 degrees right here. Okay. And then we look, and these are the legs of a right triangle. And this is the hypotenuse. And so they want to know how far is Casey, from the bottom? Well, this distance here is the same thing as this distance here. So that question mark we'll just call X. Okay, so if we look here, we have a right triangle. This is 58 degrees. This is X. And how tall is the lighthouse? It's 84 feet. But if we're looking at this triangle right here, this is not the whole thing. This isn't 84 feet. 84 feet goes from the top all the way to the bottom. So how would we know how much this is if we want to fill out the triangle? From here to here. What's the distance from here to here? The whole thing is 84 feet. Because someone said in the chat 84 feet. No, the whole thing is 84 feet, but I only want from here to here. Well, where does this stop here? It stops right here, right? The top of his head. So we need to know what that is. What is this? What's the distance from here to here? Hello? Is this thing on? Anybody?
Bueller.
Thank you. 6 feet, right? From here to here is 6 feet. So that means from here to here is what? This is 6 feet because he's 6 feet tall, right? And it translates all the way over here, 6 feet tall. So then what's the rest of it? 78. How'd you get 78? Well, it's just this whole thing, 84, minus the 6 feet tall Casey, which is 78. So that means this side is 78. So now, if we look here, if I want to know how far Casey is from the bottom, and I know how this height, and I know this angle, can't I find this? Yeah, this is a right triangle. So I have an angle, and I have the opposite leg of that angle, and I want to know the adjacent leg to that angle. So what's opposite and adjacent? Which trig ratio deals with the opposite leg and the adjacent leg? tangent. And how do you know that? Well, if you forgot, remember so, ka, toa. And if we look for the one that has opposite and adjacent, that's this one, opposite and adjacent. That's tangent, that's T. That's what the T stands for tangent. So let's write our formula. Can we write a formula? Okay, so we're using tangent. The tangent of 58 degrees is the opposite side, which is 78, over the adjacent side, which is x. There's our formula. So now we've understood the problem. Now we've connected it to what we've been learning, and we came up with a formula. So now, step 3, let's solve this. So how do we solve this? Well, it's just like we've been doing. This x, we want to get this x by itself, but we do not like an x in the denominator. We want a whole number x. So we multiply both sides by x, so that way it cancels out right here and we get it out of the denominator. And so by doing that, we get x out of here. So now we have x times the tangent of 58 degrees equals 78. And so now to get the x by itself, the x is being multiplied by tan of 58. So the opposite of that is dividing by tan of 58 degrees. Tan of 58 degrees. These cancel. So now x equals this. Now just punch that into your calculator, your handy dandy calculator. And we get 78 divided by tangent of 58 equals 48.7. 48.7 what, guys? What are we dealing with here? .7 inches, yards, meters, miles. What are we dealing with here, guys? Anybody? What are we dealing with? Inches, miles? Centimeters? What is the units in this problem? Hello? Hello, I need you guys to participate. Thank you. Thank you. Feet, because the lighthouse is 84 feet tall. Casey is 6 feet tall. So we're dealing with feet. So this is feet. Very good. All right. Nobody was participating until I yelled at you. Then a couple of you said something. So I've had 2 people participate 2 times. Thank you. So here's what we're going to do. I'm going to open up breakout rooms. You're going to work on problems 2, 3, 4, 5, 6, 7, 8. I would recommend just doing 2, 3, 4 today since it's an angle of elevation. And then tomorrow I'll go over an example from here. And then you'll do the other 3 for angle of depression. So I'll open up the breakout rooms. And you guys can work together on this the rest of the period.